Hello, my name is Alan Perez, and this is my presentation for Test 2 for ComSci 4. When it comes to lists, tuples, and sets, the best way to introduce their functionality is by giving the definitions for all. A list is a data structure in Python that is a mutable or changeable ordered sequence of elements. Each element or value that is inside the list is called an item. Just as strings are defined as characters between quotes, lists are defined by having values between square brackets. Tuples, on the other hand, is a sequence of immutable Python objects. Tuples are sequences just like lists. The difference between tuples and lists are the tuples cannot be changed, unlike lists, and tuples use parentheses, whereas lists use square brackets. Creating a tuple is as simple as putting different comma-separated values. So this is how lists and sets are connected. They're both sequencing types. So a set is an unordered collection data type that is iterable, mutable, and has no duplicate elements. And the elements in a set are called members. Python's set class represents the mathematical notation of a set, and you represent a set with curly braces.
Lists and tuples are very similar. They both have ordered items within them. The only big difference is that with lists you have square brackets, and with tuples you have either no brackets or you could have parentheses. Also, tuples are immutable, so once you define them and you already know what's in them, you can't change what's inside. Another big difference is that a tuple is faster to use, so if you already know how long you need it to be and what is inside it and you don't want to change it, then it's more efficient to use a tuple. Other than that, the functionality of a list and a tuple are pretty similar. Here in this example, we have a list named list. And here, as you can see, it can hold an integer, a string, and a floating point number. Same with tuple. With a tuple, you can either write it without the parentheses or with the parentheses, and with a list, it has brackets. And here's the part where we get to sequences. When dealing with tuples or lists, the tuple or list starts counting from 0 and then goes 1, 2, and so on, depending on how big the list is. And this is a very important concept when it comes to accessing what's inside the list or tuple.
Another thing about a set is that it's much faster than a list. So here's an example of a set. As opposed to lists and tuples, the order doesn't matter of the elements or members in a set. Also, what's unique about a set is that you can't have the same element twice, also known as non-duplicate items.
So here we have a list of numbers, and it has the numbers 10, 2, 5, 9, and 7. And if we want to access that list of numbers, we just write the name list of numbers, and let's say in this example we want to access the number 5. We're going to put 2, and this is because 10 is in the 0 position, 2 is in the 1 position, and 5 is in the 2 position. So if I'm correct, it should give us the number 5, which it does right here. And if, let's say, we wanted to access the number going in reverse, in this case, we would use print list of numbers. And let's say we wanted to access the same number, number 5. 7 would be -1, 9 would be -2, and 5 would be -3. Let's see if I'm right. Yeah. -3. Another thing we can do is check the length of a list. And the same can be done for a tuple. Here the functionalities are pretty similar. In this case we want to check the length. Then we run it. It's giving us the number 5, and the list is 1, 2, 3, 4, 5 items. Just to make sure, let's add another item. Let's say the number 3. And now the list would give, or the length of the list would give us 6. And then in this case, the number 3 changed to 9 because 9 is the new position. Because when you're going in reverse, it's -1, -2, and -3. So that gives you the length of the list. Another functionality you can do is sum up the list. Print that out. You get 36. Another thing you can do is have them sort it. So now it's 2, 3, 5, 7, 9, 10. You can do print max 10. Same could be done for the min. There you go, 2. And then another thing we could do is called sequential unpacking. So this is where you put every number in the list into a variable. So since there's 1, 2, 3, 4, 5, 6 numbers in the list, you can put those into variables, which is A, B, C, D, E, and F. And then it would equal. So here in where I did list of numbers, I just did bracket colon bracket, and what that means is that it starts at the beginning of the list and goes all the way to the end of the list. And then it'll fill in A, B, C, D, E, and F as 10, 2, 5, 9, 7, 3 in the variables given, and this is what's known as sequential unpacking. And as you can see, once we print out, it gave us exactly what was in the list. So here we're going to show the functionalities of a set, but first I'm going to create a list. You'll see why in a minute. In order to convert a list into a set, we're going to name a set set1, and then use the set function, and then type in the name of the list. And if we print set1, we should get a set. And then right there we clearly have a set. Next thing we do is that if we create a set that has multiple of the same elements or members, the set will just erase what's inside that's duplicated, as we can see here. Yep, there we go. We only have 1, 2 right there. So here we can show what's known as set comprehension. I'm just going to do a little example. 3 times x for x in range of 10 if x is greater than 5, and we check what's inside the set. We get the resulting set, but it's inputted in random order, as you can see right over here. So here I wrote out a couple of set operations, basic set operations, and I took the set from set 2 from the previous example and used it in these examples. So the first method I used was the add method, where you add 3 into set number 2. Next I used the remove method to remove the number 3 from set number 2. Then here I used the len function on set 2 to check how long it is, to check how many elements or members are in set 2. Next I used the in function to see if the number 2 was in set 2. Then I used the not in function to see if 2 was not in it. Both of these will give you a Boolean value. This should return true and this should return false. Then we use set2.pop, which will pop one of the elements or members out of set 2, but it will be random because there is no order in set 2. And then lastly I use set2.clear in order to clear the set. And let's run it. So here, as you can see, it did add the number 3 to it. And just because it's 1, 2, 3, that doesn't mean that it's ordered in that way. It just so happens to print out that way. And then here, when I use the remove method, you can see that it removed the number 3. Then it checks the length, and there is only 1, 2 elements or members in that set, so that is the value 2. And then the first one we said we were going to get a true Boolean value, and we did. And then the second one we said we were going to get a false Boolean value, which we did. And next I used the pop method on set 2, and it picked number 1 at random. And then set.clear emptied set 2, and then here it just returns an empty set. So finally, the last thing I'm going to show you are the standard mathematical set operations. First one I'm going to show you is set 1 and set 2, which will give you the intersection between sets. And if you know your logic gates, it's an AND gate. The second one is set 1 or set 2, which will give you the union between sets, or the OR. And then this one is the set 1 and then like a little arrow pointing up, which will give you the system difference, or the exclusive OR. This will give you the items that are in set 2 but not in set 1, or vice versa. So here we have set 1 minus set 2. That's pretty self-explanatory. It's just the difference. It returns the value of what's in set 1 but not in set 2. Then the last two just give you Boolean values. The first one checks a subset. It checks to see if set 2 contains set 1, and then the second one contains a superset to check if set 1 contains set 2, and then we run it. Okay, so here we have set 1 and then here we have set 2, and for the first one we were checking the intersection, and here we get 1, 2, 3 because it's in both set 1 and set 2. And then the second one we check the union, or OR, and this gave us 1, 2, 3, 4, 5 because it's in both set 1 and set 2. Gives us all the values in set 1 and set 2. And then we did the system difference, or the exclusive OR, which is 4 and 5, and we get the same value for the difference when we subtract. And then finally, for checking the subset, we get a false because set 2 does not contain set 1. And then for a superset we get true because set 1 does contain set 2.